Kia ora, year 10. This is video 4 going over the relational questions in an old exam, just to give you some revision across lots of different topics. So some of these are not covered in 2021. I've just put a cross through them. I'll show you those as we go through. So we got up to question 7. We're still in the middle of a bit of algebra. We need to factorise these expressions. So what are we looking for? Well, I've got this term here and this one here. I'm looking for the numbers first. So the highest common factor in the numbers here is 4. Then I'm looking at the x's. The highest common factor, the highest common factor here is x squared. And then the highest common factor in the y's is just y. So we have to now get back to this. So 4, what's a 24? I've got 6 here, I've got x here and y here. And then just plus 1, because all of this is the common factor. So that's that one. Okay, what's next? Let's have a look. This is a quadratic, and this is my easiest quadratic pattern. I can see that I'm going to have x times x, and I've got a plus here and a plus here. So the sign pattern that's going to work is one with a plus plus, two numbers that multiply to 10 and add to 7. So it's going to be 5 and 2. Right, so that's the end of that one. The next one is another quadratic. This time the sign pattern is a plus and a minus, right? And I know that because when I look at this, I'm going to generate that negative 24 by multiplying these two things together. So I need a positive number times a negative number, and I want the gap to be 5 with the bigger number being a negative. So let's try 8 and 3, and we can expand that out to check. So we get x squared plus 3x minus 8x minus 24. Yep, so that looks right. Okay, so you don't have to write all of this, but this is a useful habit to get into to check them back. Now in this next one here, first we have to take out the highest common factor in the numbers, which is 3. So we get 3 times x squared minus 36. And hopefully, if you're watching this, you spot that this is our difference of two squares pattern. So we've got 3 here. And we don't want to have an x term coming up in my quadratic, so it's going to be x plus something and x minus the same something. And it needs to be the square root of 36. So it's going to be x plus 6 times x minus 6. You'll be seeing a lot more of that pattern over the next few years in algebra. Okay, so now we're on to solving equations, right? So remember, that's different from up here, where we've got factorising expressions, right? So all of these things are not equations. They don't have an equal sign. But these ones down here are equations because we're trying to find the value of x that makes the statement true. Now we've got one inequation in here, and the inequation is this one here. And these work just about the same way as equations. I'll show you that one when we get to it. So for the first one here, 8a, we're going to expand it and get 4x minus 20 is equal to 13. 4x is equal to 33. So x is equal to 33 over 4. The next one, well, I've got 5x and 2x. And then I've got the plus 3 and the minus 15. So I want x's to one side, numbers to the other side. I'm going to start by subtracting the 2x from both sides. I have 3x plus 3 equals negative 15. 3x is equal to negative 18, subtracting 3. And lastly, dividing by 3, I get x is equal to negative 6. I'm going to come back to this one. The next two are quadratics. Now, when we're trying to solve a quadratic, the best way to approach it is to try and write it as a factorised quadratic. The reason for that is that 0 times anything is equal to 0. So if I can make either of those factors 0, then I'll have 0 times something. So either x plus 5 is equal to 0, or x minus 2 has to equal 0. And that means x is equal to negative 5, or x is equal to 2. All right, this one here is not factorised yet, so that's the first step. I'll start by factorising it. So I'm looking for a plus minus sign pattern. I'm going to have x minus 7 and x plus 3. And following the same logic as over here, that gives me x is equal to -3 or x is equal to 7. So lastly, I'm going to come back to this inequation. Now, with inequations, we've done this very briefly in class, but we're going to do it again now. Basically, we treat it exactly like an equation, except that if I am multiplying or dividing by a negative number, then I change over a greater than sign to a less than sign and vice versa. You've probably forgotten what I'm talking about, but it works like this. Think about your number line. Let's draw a number line. Here's my number line. Here's 0. Here's 1. And here's 2. Now, if you're the person out there that really doesn't like the sparkly thick pen, I'm really sorry, but you'll just have to put up with it. There we are. We've got 0, 1, and 2. Now, we know that 2 is bigger than 1. But let's think about our negative numbers. Here, we've got -1 and we've got -2. We know that -2 is less than -1. So, if I'm working with a number is bigger than 2, and I take its negative, so I times it by -1, and I say the negative of the number, well, how does the negative of that number relate to 2? So the number is bigger than 2, means the negative of that number has to be smaller than -2. And that's how we get our rule about switching over the sign when we're timesing or dividing by a negative number. And that's the only time we have to really think hard about these inequations. So let's just attack this one here as if it were an ordinary old easy Year 9 equation. The first thing that I'm going to do is to subtract 19 from both sides. That leaves me with -3x is less than -19. So here's 0, -11, take away 19, gets me to -30. So -3x is less than -30. And now I need to divide both sides by -3. So if -3 times the number is less than -30, then x has got to be greater than 10, right? So where did that 10 come from? Let's go more slowly. So we're going to divide both sides by -3. That means we have to switch the sign. So -30 divided by -3 is 10. So my final answer is x is greater than 10. Right, going quite slowly. I've got a wee bit to get through yet, but the next few are ones that are not covered this year because we're saving some of these questions till year 11. So we're not doing question 9 or question 10 or question 11. Now question 12 and 13 are just some trig that hopefully won't feel too difficult. So in 12, we have to find the length of the missing side, it should say. The missing side here is length B. So labeling, this is the opposite, this is the hypotenuse. So we have sine of 63 degrees is equal to 13 over B. So it's one of these ones where the thing we don't know is in the denominator. So B sine 63 is equal to 13. B is equal to 13 over sine 63 degrees. And I'm not going to work it out until the end because I don't want to round too soon. But now when I get that, and I get, I think, 14.59 something, 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 I'm going to round that to 14.6 meters, right? So just check what is B. B is a length, and the units are meters. So that's that one done. Now the next one needs us to find two things. First, we have to find length Y, and then we have to find length X. So what am I doing first? I just want to see if I've actually finished this one off. I don't know if I have, so I'll do most of it. So the first thing I'm looking at in here is that I don't have enough information here yet. The only thing I've got to work with is this small triangle over here. And I know this side, and I know this angle, so that means that I can get this one here. I'm going to erase that big mess now. Now, once I've got that extra side there, I can find X and I can find Y. So the first thing I'm going to do here is give this a letter. So let's call this Z. And now we've got the opposite side here and the hypotenuse here. So sine of 64 degrees is equal to, let's make that a bit thicker, sine of 64 degrees is equal to z over 4. So 4 sine 64 degrees is equal to z. So z is equal to 4.4504 centimetres. Now I'm not going to round that too hard because I'm going to use this with these now. So the next thing to do, I'm going to find the angle here, and we know that side length now, so we can write that on. It's 4.4504. So this is the opposite side, and this is the adjacent side. So we're going to do tan, so angle x, so tan of x degrees is equal to 4.4504 over 7. So x is equal to tan inverse of this. And when I did that on my calculator before, I got 32.4 degrees. Now, I haven't worked out why, because I completely forgot to do that when I was preparing this video. I'm going to show you how to do that now, and you can just do that one for yourselves. It's not too hard. Okay, well, there's two ways to do it, actually. The first way, hopefully you can see, is to do it using Pythagoras, and that's fine. That's probably what I would do here, right? So I can start that off, but I just haven't got a calculator handy. We're going to have 7 squared plus 4.4504 squared is equal to y squared, and so on. So that turns out to be an easy short side Pythagoras question. Right, question 14. Just trying to get through this before 15 minutes is up and the video runs out. We've got to write the equations of the graphs. So we're looking at these. We know that they're going to be in y equals mx plus c form. So let's see what we've got. Well, this first one has got a y-intercept here. So it's going to be y equals something x plus 2. Now we find the gradient. We've got two blobby points here and here. So we're going out 3 and up 2. So my gradient is 2/3 of x plus 2. For this next one, it's going to be y equals something x minus 3. There's my y-intercept. Two blobby points. I'm going to go out 2 and down 3. So it's going to be negative 3 over 2x minus 3. So there's that one and that one. Let's see what's left. Okay, so question 15 is parabola graphs, which we're not covering this year. We think we've done enough. So that's all for now. The next video I do will go through some extended abstract questions, so make sure that you're ready with your book and your best maths brain. I'll do that soon. Thanks for watching.